Tutor, where school is made simple. Let's go.
When working with trigonometric functions, we often come back to the mnemonic tool SOHCAHTOA to help us define each of the three trig functions. The first part of SOHCAHTOA identifies the sine as being the opposite over the hypotenuse. Similarly, the cosine is identified as the adjacent over the hypotenuse, and tangent as the opposite over the adjacent. Now we're going to try to apply this to the unit circle by picking a point P somewhere on the unit circle, and then constructing a perpendicular line through point P and the x-axis. This will allow us to identify 3 points of a right triangle, and then construct our triangle likewise. Now, using the conventions that we've established since pre-algebra, we identify the horizontal component as being x, the vertical component as being y, and of course, because it's a unit circle, we know that the hypotenuse is going to be 1. Now, if we apply the Pythagorean theorem to this, we will find that x squared plus y squared equals 1. Now, you'll recognize also from Algebra 2 that this is the algebraic definition of a circle with radius 1 and center at the origin. Now that we've established our right triangle, let's try to establish what sine of theta would be. And working from the definition of sine, we say that it would be the opposite over the hypotenuse. The side opposite of theta is the one directly across from theta, which would give us opposite being y and the hypotenuse being 1, which simplifies to y. Similarly, if I was looking at the cosine of theta and using the definition of cosine, which says adjacent over hypotenuse, we would look at our angle and say, what is adjacent? Which leg of the triangle is adjacent? It's not this, because this is a hypotenuse. So it would be x. Therefore, cosine is adjacent over hypotenuse, which would be x over 1, which simplifies to x. Now that we've established that x equals cosine theta and y equals sine theta, we can then substitute into our original formula and find that cosine squared plus sine squared equals 1, which is one of the most integral identities we will use with trigonometric functions. Many of the other identities we use derive from this.